This is regarding quiz A.1, A.3. I wanted to go over a few of the major problems that happened on the quiz. Actually, we'll probably briefly run through the whole thing, but I want to make it quick and don't want to make this file size too big. This first question, number 1, is just plug it in your calculator. You should get 0.187 or 0.188, depending on if you round or truncate. I accepted both. Number 2, we have a difference of squares. 10x is being squared in the first spot. 9 is being squared in the second spot, and plus or minus. Remember that we're using the form a squared minus b squared equals a plus b, a minus b when we're factoring completely. Number 3, factor by grouping. When we have 4 terms, some of you tried to treat it like a trinomial, like you do in number 4, but it is not a trinomial. It has 4 terms, and usually factor by grouping is handy in that kind of problem. Look for the common factor in both. You want to factor out a -4 out of the second pair so that we can get these quantities to be the same. Good news for us. And actually a lot of you got to this point, but then you stopped. This is still factorable, and you must factor it. The instructions do say to factor completely. So you got x plus 2, x minus 2 for another difference of squares. Number 4. You have a leading coefficient of 1, and it's a trinomial that's quadratic in form because of the square. So you can jump right to quantities with x's in the first spot. You want 2 numbers that multiply to give you -30 and add to give you -13. A couple of you said it was prime. The most common mistake was picking numbers -10 and 3, but really you want -15 and +2. We actually ran into this in class. Number 5, we always want to look for our common factor first, and we did in the other problems. There just wasn't any. In this one we have x squared, and that makes the trinomial we need to factor a little bit more easy to factor. Some of you still got through the adversity of trying to factor a 3-term, or trying to factor a trinomial of a 4th degree. You could avoid that mess. Now, because we have a leading coefficient that is not 1, we can use the grouping method. Multiply these 2 numbers to get -90. You want 2 numbers that multiply to give you -90 and add to give you -1, the coefficient of that middle term. Those 2 numbers are -10 and 9. So you rewrite your middle term using the 2 numbers you found, and if we find the correct numbers, it's going to be factorable by grouping. So factor out 2x, 3x minus 5, factor out a 3, 3x minus 5. Yay, our quantities are the same, so it is a common factor that we factor out. Notice all along that this x squared is just coming along for the ride. It's a GCF we factored out at the beginning, and that's it. So write your common factor, write what you have left, and you're done. Number 6, we did one of these in class. I think Oliver was the only one to expand it. There might have been one other person, but he actually expanded this whole thing and factored that, and that could take forever for some. Oliver has a strength with numbers, so he was able to get away with it, but the easiest way is to factor out a common factor. We have a 3 minus 4x in both of these products, so we'll factor it out. You're left with 5 and a 3 minus 4x in the first spot, then minus 8 times 5x minus 1 from the second product. Now the 3 minus 4x comes along for the ride. 15 minus 20x, yada yada. Combine like terms, and you get this, which is finished. And you're factored. Now I don't want to go over every problem. Silly mistakes on 6a and 6b. Your answers were -4 and -7. A was u to the 5th over 2w to the 4th. B was 1 over x to the 4th. Find your mistakes. I'm sure they'll make sense to you. C and D were generally correct, or generally got correct by most of you. Okay, I like to simplify square roots by separating my perfect squares and then simplifying that particular radical. Some of you do the factor tree method, whatever you're comfortable with. At the end of the day, you're doing the same thing. You have 3 perfect square factors in there, a 9, an x squared, and a y squared. 2y left over. Notice how this product equals what we started with. 18 is 9 times 2. X squared is a perfect square already. And then y cubed is y squared times y. This whole radical simplifies, and you're left with 3xy times root 2y. And I didn't write in the instructions, but our assumption in class, this is really the absolute value of x, but I'm not even going to go there. We're assuming our variables are positive for what we're doing. If you want to discuss that further with me, you can. F, separating your perfect squares again. And just showing every step. And we got 26 root 2. This you rationalize, multiplying the top and bottom by root 2, because that makes the radical go away in the bottom. It simplifies to root 2. Yes, you did lose credit for not simplifying to that. This one you just add exponents. You can multiply to 3 and to 6, because this is really just one giant product. So 3 times 2 is 6. X to the 2/5 times x to the 3/5, you add exponents, you get x to the 5/5. And you need to simplify that to just 6x. Big problems with I. The negative exponent means flip. So you got 1 over 64 to the 2/3. Then some of you did do this, but you had trouble dealing with the 64 squared. Fine. You don't have to deal with the 64 squared if you bring the square outside. The cube root of 64 is 4, so you end up with 1 over 4 squared, which is 1 over 16. In decimal form, not many big problems there, and it turns out that this is the width of a human hair. I think two of you got that, I believe. 9.46 times 10 to the 15th kilometers. Only one person got it. Another person got close. I think it was Gino, who said it was a light year, and indeed it is. That was a nice catch by Gino. This, just distribute the negative. That was the most common issue. Minus 3x minus 8 plus x squared. So you got 2x squared minus 3x minus 5. I took this problem off. In interval notation, so if x is at least 2, that's true, and it has to be less than 4, so that's true. Take one more step, writing in an interval notation, and that's your answer. If you want to talk about the replacement problem, we could do that in extra help, but your answer to the replacement problem was 192 root 2 square inches. Okay, hope this helps. If you have any further questions, come to extra help or ask in class.